general gas equation under gas laws. So lastly, I talked about Boyle's law and Charles law, and I said the formula for Boyle's law is P1 V1 equals to P2 V2. Then for Charles law, it's V1 all over T1 equals to V2 all over T2. So general gas equation is combining both Boyle's law and Charles law together. So the law states that the pressure and volume all over temperature of a given mass of a gas is constant. That the pressure and volume all over absolute temperature of a given mass of a gas is what is constant. So our formula will be P1 V1 all over T1 equals to P2 all over V2 P2 V2 all over T2, right? So over here we have two solid questions which I would want us to solve in the next few minutes. So the first question says, at STP, I told you what STP is, standard temperature and what and pressure, and I said the standard temperature is what? Standard temperature is equal to is 0 degrees Celsius, which is the same thing as what? 273 what? Kelvin. And then we have what? Standard pressure. So this is your temperature and this is your what? Your pressure. Your standard pressure is 760 millimeter mercury or 1 atmosphere, or we have it to be 1.01 times 10 raised to the power of
5 Newton per
Newton.
meter square.
So these are your what? Your standard what? Temperature and what? And pressure. So now let's go down to this question. So this question says, the question says, at STP, a certain mass of gas occupies a volume of 790 centimeter cube. Find the temperature at which the gas occupies 1000 centimeter cube and a pressure of 726 millimeter mercury. So for us to solve this question, we are going to apply this formula of general gas equation, which is coming from what? Boyle's law and what? Gas and Charles law. So let's solve the question together. So solving that, you say the formula is what? Pressure 1 volume 1 all over what? Temperature 1 equals to pressure 2 volume 2 all over what? Temperature 2. So like I told you when I was teaching gas law, please, if you've not watched, if you don't understand Boyle's law, just check under the description, you see the video of Boyle's law. So P1 V1 all over what? T1 equals to P2 V2 all over what? T2. So at STP, a certain mass of a gas occupies a volume of what? 790 centimeter what? Cube. So in this case, your STP is what? Is your pressure 1 and your what? Temperature 1. Then you are being given what? V1, which is what? 790 centimeter what? Cube. So at STP, pressure 1 will be what? 760 millimeter what? Mercury. Because why? We are dealing with volume. Volume is in centimeter cube. So your V1, so your P1 will be what? 760 what? Millimeter mercury. So your T1 is what? 273 what? Kelvin at STP. At STP. So the second part of the question says, find the temperature. Find the temperature at which the gas occupies 1000 centimeter cube. 1000 centimeter cube. So that will be your what? Your V2, which is what? 1000 centimeter what? Cube. Right? And a pressure of 726 millimeter mercury. And a pressure, so your P2 is what? 726 millimeter what? Mercury. So what are we looking for? We're looking for what? T2. So make T2 subject of formula, right? So T2, you say T2 is equal to what? This is our T2, right? So is equal to what? P2 V2 T1 all over P1 V1. So the next step is what? Substitution. So we say T2 is equal to what? What is our P2? Our P2 over here is what? 726, right? Millimeter mercury. That is our what? Our P2. Then our V2 is 1000, right? Centimeter what? Cube, right? Times our T1. So our T1 is what? 273 Kelvin, right? So all over. So what is our P1? Our P1 here is what? 760 millimeter what? Mercury times what? Our V1. What is our V1? Our V1 is what? 790 centimeter what? Cube, right? So millimeter mercury cancels itself, centimeter cube cancels itself, right? So over here, what we are going to have as our final answer is what? So 726 times 1000 times 273 divided by 760 times 790, you're going to have what? 330 point what? 1 Kelvin. You're having 330.1 Kelvin. So this is our final answer for this question. So now let's answer the second question. The second question says the volume of a given mass of a gas is 300 centimeter cube. The volume is what? 300 centimeter cube at 27 degrees Celsius and 700 millimeter mercury. So our formula P1 V1 equals to what? Sorry, all over T1 equals to P2 V2 all over what? T2. So our P1 is what? 700 what? Millimeter mercury, right? Then V1, our V1 is 300 centimeter what? Cube. Our T1 is 27 what? Degrees Celsius. Our P2 is 750 millimeter mercury. Our V2 is not given because the question says what is the volume at what? 36 degrees Celsius. So our D2 is equals to what? 36 degrees Celsius. And then first we are going to convert the degree Celsius to what? To Kelvin. So 27 plus 273 plus 27, we are having 0, 0, and 3. So over here we have what? 300 Kelvin, right? So for the 36, 273 plus 36, we are having 903. We are having what? 300 and what? 9 Kelvin, right? So the next thing is to make V2 subject of what? Or formula. Making V2 subject of what? Formula. So making that, we have it V2, which is what we are looking for, is equals to P1 V1 T2 all over P2 T1. So we say V2 is equals to, our P1 is what? 700 millimeter mercury. That is our that is our P1, 700 millimeter mercury. So times our V1, which is 300 centimeter cube, times T2. So our T2 is what? 309 watts Kelvin all over P2 is what? Is 750 millimeter watts mercury. And then T1 is what? 300 what? Kelvin. So that is 300 Kelvin. So Kelvin cancels what? Kelvin. Millimeter mercury cancels what? Millimeter mercury. So what is the answer? 700 times 300 times 309 all over 750 times 300 is going to give us 288.4 what? Centimeter cube. So this is our answer. So I hope you understand general gas equation. General gas equation is the combination of what? Charles law and Boyle's law, and which the formula is what? P1 V1 all over T1 equals to P2 V2 all over what? T2. And the law states that pressure volume all over temperature of a given mass of a gas is what? Is constant. So in this case, we have come to the end of this today's class. Please drop down your question in the comment section, subscribe and share this video. See you in our next class. Thank you.